So the other version of this, what we talked about, on the engine displacement, is on this particular engine here, and this one is I did this one off of one of the engines we have at the lab area. It's bore times stroke times 0.7854. So if we have the bore at 4 inches measured from top to bottom, left to right, and then we've got the stroke, and say we measure it at 3 and 7/16. Well, that's not a good number there. We have to convert that number. So you're going to divide 7 into the numerator to the denominator, which is the 7 divided by 16ths. And that'll give us 0.4375. So you basically take the 3.4375 and plug that into the formula there. This is a very important formula for engine displacement. And I show this in my PowerPoint too, by the way. So this is just kind of reiterating what we're doing here. So, I've got 4 times 4 times 3.4375 times the 0.7854. Now that number replaces the pi number, which is 3.4444 infinite. And that'll give us a 43197 cubic inches. So that is going to be our piston displacement for that one particular cylinder that I measured. Then you're going to take that and multiply it times 8, because we have an 8-cylinder. And that gives us 345.576 cubic inch displacement. Okay. Now we need to take that number and we're going to convert the cubic inches to cubic centimeters, which is going to be multiplying that 345.576 times 16.39 cubic centimeters. Okay, because we have to have it in cubic centimeters. Once we get that in cubic centimeters, that's multiplied times 16.39 is going to convert that to cubic centimeters, which is 5.6639906. And then we're going to take that number and we're going to divide it by 1,000, which is the conversion number for converting cubic inches into liters. And that gives us 5.6639. And then we can round that off to a 5.7 liter engine. So that's kind of what it looks like right there as far as the conversion for engine displacement, and converting it from where we used to be in cubic inch displacement, now converting it into liters. When you get into the metric system, you're going to have to, if anything is in as far as the numbers in metric, like 85 or 85.4, you're going to have to get that number. And what we're going to have to do on that is we're going to have to convert it. And on the upper right hand corner, I have the conversion from inches to millimeters. From inches to millimeters, we're going to multiply it times 25.4. From millimeters to inches, we're going to divide it by 25.4. Okay, so if we have metric specifications for our bore and stroke, we have to convert that into inches, because it won't work with the formula we have: bore times stroke times 0.7854. So we're going to have to go ahead and get that number and divide our bore divided by that 25.4 to get us the conversion from millimeters into inches. So just kind of remember that, because there is a worksheet that I will be uploading for you guys regarding some metric engines that we'll be looking at doing. You will be getting one particular worksheet where you're going to have to convert. And calculate for your engine displacement and go into liters. And then there's another one where we're going to talk about for next time, which is the compression ratio. Because now we're going to take on the compression ratio, we're going to take that first reading that we calculated for a piston displacement. If you're looking at that 43197, that's going to be the key number for calculating our compression ratio. That will be on the next lecture that I will discuss there. That way, I don't want to get y'all confused, but I'll show it to you just like we do right here, which I would normally do in a classroom. So just kind of look forward to this right here. I will be sending a worksheet out on this one to do. If you have any questions, just email me. You guys be safe out there. Talk to you soon.